Okay, guys,
Alright.
I'm not sure where the video cut off, but we cut part of the video off. So what we're trying to figure out is what the cosine of 45 degrees, right? Cosine of 45 degrees?
Yeah.
You're standing right in front
So
of
if
it.
this is 45 and that's 45, your
Dad, move
triangle,
out of the way.
Right in front of it.
your triangle, looks like this, right?
Yeah.
The two sides of the triangle are the same, and this is 1 square root of 1 squared plus 1 squared, right? Pythagorean. Square root of 2. So the cosine is 1 divided by the square root of 2. I think I mentioned that at some point, right? Adjacent over hypotenuse, 1 divided by the square root of 2. What is that? What's that equal to?
I can't do that. My calculator won't accept square roots.
0.70. So 0.71.
And that's what I think you were saying is, so if you need to check things like that, you can always check it this way.
Alright.
So that's your sine of 45 degrees. Continue, Frankie.
Cosine.
Cosine.
So, dx.
What's the sine of 45 degrees?
Sine.
Oh yeah,
You
you
shouldn't need a
got
calculator for that.
0.85.
What's the sine of 45 degrees? It's opposite over hypotenuse, right?
Yeah, so it's just the opposite of
It's the opposite of that? What does that mean?
that. Okay, sorry.
Good job, Frankie's drowned it out.
Point
Yeah.
07
So it would be.
or 0.071.
Wait, what? It's opposite of.
0.07?
No, 0.70. 0.71. So sine of 30.
It's the same, right?
Yeah.
You had 1 here, square root of 2, 1 here. So 1 divided by the square root of 2 is the cosine, 1 divided by the square root of 2 is the sine. My point is that at 45 degree angle, they're the same. Sine is the same as cosine for 45. Okay, go. So cosine is 0.71 is equal to
Yeah.
Vx over V, and what are we trying to solve for?
V.
V. So solve for V.
So what's Vx?
X is
85? Or 80?
no, it's supposed to
Okay, what was the question?
What's Vx?
VX.
It's 80, right?
No, it's supposed to.
Do we know? Okay, so dx. I don't know. We don't know dx.
What was it in the last problem?
What do your notes say it was in the last problem?
Not sure.
I did as delta x in the last problem.
Delta x over t.
Okay.
Vx is delta x over t. You can see that, right?
Yeah.
Dx delta x over t. What did we do in the last problem?
Cosine theta equals VX.
Equals what?
VX over V.
Over v. And so what did we solve for?
V.
Solve for dx. No wait.
For vx.
Yeah, and we got point.
And we got 0.71 times v.
Okay, so then it would
So
be
vx is 0.71 times v, right?
Vx over V, so it would be.
And then we solve for time.
Times 1 over Vx. 1 over.
Oh wait, we're solving for Vx, right? Not V.
We already found Vx.
We're solving for time in terms of v, eventually.
Okay.
So delta x is Vix times t, right? And we just figured out what Vix is in terms of v, I think. At least I thought you were. What's Vix in terms of v?
Okay, so we're solving for Vx.
Yes.
Okay.
Solving for Vx. So you multiply both sides times what?
V.
Okay. And now your equation looks like
There you go. So now you got Vx.
times
Ix, right?
0.71 equals Vx.
So what do we do next? Look at your notes. Were your notes really that bad, guys? You don't know, you don't have any clue how we solved the last problem?
No, I wasn't looking at this.
Isaac?
Mine weren't very good.
Sine Vy over V. So we found cosine Vx over V. So now we need to find,
And then what did we do next?
then we found sine theta Vx over V.
We took this and we said now t is equal to
Sacrum
delta
Vx.
x
Sacrum.
over v, well, 0.71 v. So now we have an expression for t. And delta x, we know, is what? T is, what's delta x?
80.
80 meters. Divided by 0.71 v, so t is what? What's 80 divided by 0.71?
$111.67. Or 112, sorry.
80 divided by 0.61.
No, 0.7.
112, what? Point,
0.68.
Yeah.
let's say 0.7 over v. So now you have t in terms of v. So our first step was getting an expression for delta x, right? That's what we did here in terms of Vix. Then we got our second step was an expression for Vix in
Right.
terms of v,
Write that in the strategy, guys.
right?
First, step 1. What did you do?
Found an expression for delta x.
It might be hard to read your writing, Dale, so why don't you say what you're writing for the Coxvoice.
So find Vix in terms of t and delta x. Find the v in terms of Vix. That's this, right? Our answer. Find t. That's why I was saying that I'm not sure how many steps we're going to have to use, but find t in terms of v. Step 4,
Stay on the board.
What was our fourth step in that last problem? What do we do now? We now know what time is in terms of
No,
the
we
thing we're trying to figure
find
out.
So did you find the sign?
delta, yeah, sine theta equals By over P. That was our next step.
So we found VIY in terms of V. And that was what?
Sine theta equals By over P.
Right? So if sine theta equals Vy over V, what's V equal to?
Multiply.
V equals Vy, or
Sine
sine
theta.
theta divided by Vy.
Try again.
V equals sine theta divided by Vy.
So you're saying I would divide both sides by Vy? And that gives me V? I'm just going to save this over here so we don't lose it. Sine theta equals Vy over V, right?
Yeah.
We made our little triangle. At V, dx, dy. So, you're saying to multiply both sides of this by 1 over Vy?
Yeah.
So now I have sine theta over Vy. These cancel, and what do I have on this side?
1 over V.
1 over V. I don't want 1 over V, do I? I want V. So what's V?
Multiply both sides by V over, no.
Yeah, well, or just flip them both. You can just flip them. So V is Vy over sine theta, right? Okay, so now we start working with our y direction.
You can't go there.
Okay, well, so what equation are we going to use to describe the motion in the y direction?
Motion in direction.
Do we have velocity?
Uh,
Do we have time?
no.
Oh, yeah.
Well, yeah.
I mean, in terms of the problem. We have time, we have velocity, we have displacement. Yes?
Yes.
We have acceleration.
Yes. Oh,
Yeah, we did.
So what equation are we going to use
Delta
to describe the motion if we have all those things involved?
delta y equals VIT plus 1/2 AT squared.
Yes.
A
Thank you.
Y. A Y.
So I need to. Can you just say no over there?
I'm trapped. I need somebody to.
Oh wait, where's that? All right. So let me just transfer. We had V. is Vx equals 0.71 times V, right? I'm kind of narrowing down the things that we know. So we're going to get rid of this. And do that. So, delta y is equal to v I y times t, right? Plus 1/2 ay t squared. Right? What's delta y? Is that time already? What time is it?
Give or take.
1.8 meters per second.
152.
We should be able to finish this.
Can you break this stuff down for me? I would use this.
What's delta y?
Negative 9.8 meters per second.
Delta y?
Oh, delta y. 0.
0. What's VIY?
.71.
VIY is what? V times sine theta, which was, what's sine theta?
0.71.
Sure. Times V, right? Figured that out a minute ago. Alright, so we know VIY times T, right? So we got 0.71 V. What's T?
0.71.
We figured T out over here, right?
Yeah.
So it's 412.7 meters over V.
112.7 meters over V. Plus, running out of room again. I need a bigger board, don't I? Now I know why they have those things that go all the way around the classroom. All right, so 1/2. What's AY?
Negative 9.8.
9.8 meters per second squared. And T squared is going to be this squared, right? Times. Times this squared. Whatever that thing is, right there. Squared. Okay. So now my V's cancel.
Wait, 112.7 meters over V?
Squared. Right. What's 0.71 times 112.7?
80.017.
How did-
80?
Yeah.
How did you get your V's to cancel?
0.17. Wait, what was it?
V.
0.17?
No,
Oh.
80.017.
80.017.
80.02 what? Meters
Meters plus
plus,
half of 98, 9.8. I'm going to call that 5 just for simplicity. And what's 112.7 squared?
12,701.29.
That's close enough. Meters squared over V squared, right?
12701 meters
that-
squared over
That, is that
V2.
times 12701?
Yes. times.
Yeah, it does times.
Multiply.
Well,
times.
in that
So-
sense, you can say times. It wouldn't make sense to say times.
So I'm gonna move my 80 meters over here. Kind of interesting, it worked out to be the same as the displacement. We'll talk about that.
How
So
you-
that
how
becomes
you-
minus, right?
Mhm.
And what's 5 times 12,701?
63,063,505.
Okay, one person,
63,505.
505. And it's meters,
Negative.
meters cubed,
Negative.
right?
Because it's
Meters
negative 5.
times meters squared, meters cubed per second squared divided by v squared. Right? Solve for v squared.
Negative
One.
63.
Get rid of my negatives like we did last time. V squared is now 63,505. I'm speeding up a little bit because we're running out of time. Meters cubed, second squared, right? I can move my V over here and my 80 over here. So, what's 63,505 divided by 80?
793.8125.
Is what?
793.8125.
Meters per second squared.
Yeah.
Meters squared per second squared. Because this is cubed, so one goes away and this becomes squared, right? So, what's V?
Think
28.17.
you took the square root of it?
28.17.
I
So there's your velocity, there's your quarterback's FPS.
This wasn't easy. This was like super hard. It was like a short problem. It was very like.
I know. That's the thing about physics. Very short problems can be very puzzling.
Yeah. Just like flash. Oh,
But you gotta be disciplined about just taking step by step by step. Because you see what we did in this equation here, we ended up with, the only thing in there was V, and so we could solve for V. So we got everything, we got all of our other things all in terms of V. We got time in terms of V, we got Vx in terms of V, we got Vi in terms of V, and then you can plug it in there, and all you have to solve for is V. Make sense?
Yeah.
So we're not moving on until we get these down.
Right. You guys need to be able to stand up here and do exactly what I just did with confidence.
This is
And
gonna be
the
a
way you do
four-year
that
course.
is practice. What?
This is going to be a 4-year course.
Maybe it will. It doesn't matter to me. I got time, I hope.
You won't have time.
So,
In terms
DL,
of date,
in terms of the homework, what is the homework going to be?
I
No
haven't
reading
assigned it
ahead?
yet.
No reading ahead?
Well, they're already reading the force chapter, right?
Yeah.
I don't know if you've already even finished the force chapter.
I haven't started it. I think.
But the main thing is working these problems.
Okay.
And so we need to work these problems over and over and over until we get comfortable working those problems.
This is my homework from like 3 weeks ago that I forgot to turn in. So if it's like not the right standards, it's because it was like 3 weeks ago.
It was pre-dictates. All right.
Here's the good news, you guys.